x equal to 0 and 3x plus 12, you're left with negative 12. And then when you set x equal to 0 and x minus 2, you're left with 2. And then now you'll do the same for the denominator. When you set x equal to 0 and x minus 1, you're left with negative 1. And then when you set x equal to 0 and x plus 5, you're left with 5. So now you will multiply these, and it'll end up giving you the ratio of negative 24 divided by negative 5. So now you divide negative 24 divided by 5, and you'll end up getting 4.8. And this will be your y-intercept. So you'll go to 1, 2, 3, 4, 4.8. It's almost to 5, and it'll be right here, and this will be 4.8. That's your y-intercept. So now all we have to do is find the vertical asymptote and the horizontal asymptote. To find the vertical asymptote, you set the denominator equals to 0. So the denominator would be x minus 1 and x plus 5. When x minus 1 equals 0, x is equal to 1. When x plus 5 equals 0, x is equal to negative 5. So these will be your vertical asymptotes. So x equals 1, you would plot that on 1, but you would draw a dotted line down, crossing the 1 mark at 1, 0. And to plot the x equals negative 5, you would draw another dotted line going down vertically, crossing negative 5, 0 on the x-axis. So now we have to find the horizontal asymptote. To find the horizontal asymptote, you have to look at the degrees of the polynomial in the numerator and the denominator. So this would be the unfactored form from the original equation, 3x squared and 1x squared. This would be the first terms for both of the numerator and denominator. As you can see, the polynomial degree in the numerator is equal to the polynomial degree in the denominator. So when this happens, the horizontal asymptote would equal the ratio of the coefficients of the numerator and denominator in the function. So the ratio would be 3 to 1. So when you divide this, you would get 3, and 3 would be your horizontal asymptote. And you mark this by drawing a dotted line horizontally across 3, 0, 3 on the graph, which would be this. So now to complete the graph, you would draw a line going up through this x-intercept, which would be negative 4, going up through the y-intercept of 4.8. And then you would draw another line going up through this x-intercept, which would be x equals 2, plot it at 2, 0, and then curve it like this. Now we move on to transformations of rational functions. When doing transformations with rational functions, we're going to use the function f of x equals 1 over x. Since that's the paired function, and that's what we can use to transform this function. So f of x equals 1 over x looks like this. So now we're going to shift the original graph 2 units down, which will look like this. This would be at 0. This mark is at 0. So when we shift the units down, we go from 2 mark, and then we would shift this one down to 2, so it'd be almost like we're drawing a line across, and then you curve the line down right here. So this would make the new equation be f of x equals 1 over x minus 2. And the minus 2 would be the h, which should be the vertical shift. And the vertical shift would be a factor of minus 2, which would shift the graph down more. So now we will move on to rules when finding asymptotes with rational functions. We will use this as a diagram of what I will be talking about in this part. P of x equals a to the m power over a to the n power. When m equals n, this is when the horizontal asymptote equals the ratio of the coefficients in the numerator and denominator. When m is greater than n, there will be no horizontal asymptote. When m is less than n, then y. When m is less than n, y is equal to 0. And when m is greater than n by 1, a slant asymptote will be formed. And this concludes the lesson for radical and rational functions.